Good afternoon, everybody. If you saw my face for just a moment there, I did turn it off. I wasn't prepared to have my video camera on. Welcome. We are going to get started here in just a moment. Actually, I think we can go ahead and get started. I think we're pretty much right at 3:45. So welcome. So happy to have all of you. I'm going to send you a quick, something's going to pop up in your questions panel. You can go ahead and respond there. If you, I need to send it to everybody. Let's try this again. It just says welcome. You can type questions and comments here in this section for the webinar today. So if, Ann Elise stops for a moment and asks something, feel free to respond there. Or if you have something that you want to ask her at the end towards the Q&A, you can put it in there at any point and I'll flag it and we will ask it aloud. Okay, you should be seeing it any moment. Okay, so just a couple of housekeeping things before we get started. This is your webinar panel as an attendee. You are coming in on mute. That is a default, so we will not be unmuting. It's easiest to use the computer audio. If you're having trouble with it, just flip over to the phone. You can do that in the audio section. The other thing is that if you, for some reason, cannot see Ann Elise, because Ann Elise is on video right now, so I can see her. If you can't see her or you can't see the screen, it's likely that you don't have the webinar window open. So you go down to the bottom where your toolbar is and there's a little kind of blue flower icon looking thing. Click that and make sure that that is open and maximized so that you can see the windows. The video for Ann Elise will just appear above her presentation. So it's super easy to see. As a reminder for those of you who have come to webinars before, you do get a follow-up email, and that follow-up email is going to include a couple things. It's going to include the link to watch the recording. It's also going to include a certificate. If you are watching this as a recorded webinar and not attending live, you will not receive a certificate. The certificates are automatically sent by the system based on those who log in and attend using the registration link that they got when they registered. So if you are here today, you will receive that. That'll go out in about an hour after we wrap up. If you don't see it, please check your junk and spam. I don't have any control over where it goes. I just know that it often gets filtered out. So please check those other folders and the subject will be thank you for attending the webinar. And then the other thing is that there are some codes that Ann Elise is going to share today. The demo of the braining camp, the 60 days, that is only good for today, April 13th. Is that what the date is? Did I get that right? Yes. It is, yeah. So if you're watching this after April 13th, you can always visit Hand to Mind and request a demo there. So I am so excited to have Ann Elise. We love having her. She's just full of knowledge and shares a wealth of information with you all about manipulatives. I'm going to pass things off to her. While she is getting ready, I'm going to actually launch a couple polls here. So it will pop up in your panel and you can answer it right there. So the first one is just asking you what your role is. So I have launched that. So if you would just take a moment and tell me what your role is. At some point, I'll get Jeopardy music to play in the background when this is happening, but I have yet to remember to do that. It feels like it's appropriate. Okay, we have what, 75%? Pretty good. Okay, so we are looking at 31% K2, and actually just about the same are administrators. So awesome. I have one more, and this is more about your use of manipulatives. So just so that we can get a feel for, what it is that you use already. Are you using manipulatives every day in your math instruction, weekly? That could be 2 times a week, 3 times a week, maybe not every week, but definitely every month or not very often. Okay. All right, we are looking at, Ann Elise, about 43% daily, 37% weekly.
Great. Well, that's
All
super.
Right.
Yeah.
I am done with my polling. You can go ahead and take it away.
Great. I just want to make sure that my screen is being seen right now.
Yep. Yep.
You able to see my screen?
Yes. Are you going to put it in the slideshow mode? There you go.
Yeah.
Perfect.
Yep. So there we go. How does that look?
Perfect. Looks good.
Super. Okay. my screen now shows my own face. Are you able to see, yeah, are you able to see my screen now without my face?
I can see you and on top of the presentation and the presentation, so it looks great.
Gotcha. All right, super. So welcome everyone. I'm so thrilled that you've chosen to join in today. I know life right now is insane. And I know a lot of people are going back full time, face to face, 5 days a week to the rest of the school year. Those of you who have not been face to face yet. And so a lot of stuff going on right now. So the thought that you're joining in for this webinar is amazing. So thank you so much for joining me for this time together. So we're going to talk today about hands-on math tools. So the power of manipulatives to help. Now in the title here, to stop learning loss in its tracks and propel students forward. So I do want to let you know that I'm an independent consultant, and you can always find out more information about me on my webpage, anneliserecord.com. And I'm just thrilled to be with you. I live in Concord, New Hampshire. So I'm coming to you from New Hampshire, where it's been sunny and like 70 degrees. So it's a huge heat wave for us. So exciting. So our agenda today is to talk first about learning loss versus unfinished learning. And then strategies versus models, really important as we explore math concepts, so we know the difference between strategies and models. And then I want to take you through each of the operations, just a really quick way for each of the operations, and showing how what we can do with the basic facts can be extending to the higher numbers with decimals and fractions, to show that connection and the key to that, how we can help our students be accelerating forward based on the progressions within each of the math concepts. And I'll be using a variety of the manipulatives today to show you. I'll be using Braining Camp, which is a virtual manipulative site. The research has shown that physical and virtual are equally as powerful. So it's not an either or, but it's a both and. We want to use both. And so I'll be showing that to help facilitate my session today, the Braining Camp site for that. So we will have questions at the end for any questions and answers. So feel free to put them in the chat bar as well as we go. And then at the end, we'll be going through some questions. So I want to just begin by sharing a little bit about my math journey, because I consider it, I'm still on this journey. I had been immersed in the world of elementary mathematics for at least the last 7-8 years. I had been a grade 5 teacher for 13 years, then I became math coach, K5, and now I'm an independent consultant. But I'm still on this journey. The more that I learn, the more I realize I have to learn, honestly. So it's just been an amazing journey for me. I am still on it. I hope to have you join me on this journey. And just let you know, I've been seeing it from lots of different perspectives, from tutoring people to pass the praxis test. I am the New Hampshire Teachers of Math elementary representative right now. I present for BER across the country. It's been virtual this past year, but it will become back in person again next year. And also being an author with Dr. Nikki Newton, Dr. Allison Mello. I'll share that book with you toward the end. I do want us to talk a little bit about the growth mindset, the idea that the research has shown that our brains, way our brains learn, is to connect our new learning to what we already know. And as our brains are learning something new, synapses are firing, they're trying to make new neural pathways in our brain, similar to a beach path. You've done a beach path once. If you don't do it again, the grass would regrow and you wouldn't have that pathway. But the more you go down a pathway to the beach, it creates a permanent pathway, just like in our brains. So we want to be creating these pathways for ourselves as well as for our students to be able to build the understanding from what we already know to what we're learning that is new. Once the connections are made and we keep practicing in that way of thinking, it becomes a permanent pathway that we then attach new learning to. So it's not as easily forgotten because we've been able to make those pathways in the brain and physically changed the way our brain thinks. So I'll talk to you for a second about this learning loss versus unfurnished learning. I think the words we use are so crucial that, the idea of learning loss and these gaps in understanding for our students, it's very negative connotations, right? So I don't want to think about it as learning loss. I feel like you can't learn something, you can't lose something you haven't learned yet, right? So the idea that our students are, they're behind right now in what we're thinking of without a pandemic having happened, where our students would have been at this time in the year. But of course, we don't want our students to ever feel labels that they're somehow, it's anyone's fault or that someone isn't doing as well as they should, right? So I really like the terminology of unfinished learning. So what we had last year with the pandemic, we shut down, we have had this unfinished learning. So how can we move our students forward? Because we've always had students in our classrooms that are at different places on their journey, right? So first of all, I want to make sure we're using asset-minded language, and thinking about what are the kids bringing to the table right now? What do they have for knowing right now that we can move them forward from there and connect all the way through the grade levels and concepts. So it's all about connecting our new learning to what we already know, building those pathways, no matter what the content is we're working on with our students. So in order to do that, we need to understand it ourselves first, right? So one of the keys is for us to understand the progression of learning. I know for myself, when I became a teacher, I got my master's degree to teach. My undergraduate is in sociology. And the one class I had for mathematics, for teaching mathematics, was math and literature, which was great to have picture books and literature. But I had taken math classes in college. So I'm sure the idea was, well, she can teach elementary age kids math. But there is an entire world of early numeracy that I knew nothing about, really, honestly. I taught rote procedurally and memorizing. That's how I had learned math. So when we understand this conceptual understanding of the progressions of the learning, we can really help vertically accelerate our students through the grades in the best of times, but also particularly now, right? So what can we do to help this accelerated learning be happening? What are the models we can use? First of all, we want to make sure that we are encouraging number relationships, that we're not relying on formulas, procedures that are memorized. There's no alligators allowed in math for greater than, less than. There's no butterflies allowed for comparing fractions. So we want to make sure we have number relationships and connect them whenever possible. We also want to be able to go through a cycle of concrete, pictorial, abstract, and not as a linear progression, not as a student's only in the concrete phase, but to connect those representations whenever we possibly can, concretely, pictorially, abstractly. And being able to do that, of course, with physical and virtual ways as well. And using strategies and models that are so powerful and versatile that they'll work with basic facts as well as multi-digit numbers, decimals, and fractions down the road. It's a whole connected learning journey for our students. So I want to just first mention my favorite manipulative, Cuisenaire rods. These are trademarked by HandMind, this color coding of them. They are linear measurement, they're in centimeters. They match the size of your base 10 blocks. And I believe that they're the key to helping us move our students from the counting phase of reasoning into additive reasoning and from additive into multiplicative. And it would be then in grade 6 with proportional and ratios as well. But focusing on the K5 journey, I believe these manipulatives really have the power to be able to transform our students' learning and their thinking. So the benchmark numbers of 5 and 10 are the yellow and the orange. So we use those as benchmarks all the time. We use the math tools that capitalize on the benchmarks of 5 and 10. The warm colors are 2, 4, and 8. That's your red doubling to purple, and the purple 4 doubling to 8, which is the brown. 1 and 7 are kind of by themselves as a color category, and then your multiples of 3 are the light green, dark green, and blue. So 3, 6, and 9. And people do call these relational rods as well because they're helping us build the relationships between the numbers. So rather than putting numbers on the rods, which I am asked a lot by teachers in my consulting work, no, do not put numbers on these rods. We want students to think about, well, if I need to find the 9 rod, well, what do I know? No, the orange one is 10, so it must be the one next to that, one less unit than that. So always referring back to the staircase. You have one of each color showing you there. And I want to use them today to show you the difference between strategies and models. So strategies are what we do with the numbers. How are we being flexible with the numbers? Models are how we can make that thinking visible concretely, pictorially, and abstractly. So for example, I'm showing you with the model of Cuisenaire rods, a couple of different strategies. So the same model, the same way of me showing you this physical manipulative, let's say we can use doubles for some facts. So for example, if I were to ask 5 plus 7 to my students, I would want them to be able to think about a derived fact if they didn't know that it was 12. Well, within that 7, the black rod is 7. So within that, there's a group of 5 and 2. I can decompose, break apart the 7 into 5 and 2. So that I can rearrange them in friendlier ways for my brain. I can think about 5 plus 7 as being 5 plus 5 plus 2. That's easier for my brain. I know 5 and 5 makes a 10. So there's just 2 more than that, which I know makes a 12. So this is a doubles plus 2 relationship because the numbers are 2 apart. But what if I also have numbers that are 2 apart? And I think about relationally that if I were to take 1 away from the 5 and give it to the 3, I could rename that as 4 plus 4. Doubles fact that I might already know. So the idea that any numbers that are 2 apart, one strategy is you can double the middle number you're thinking about that relationally again, taking one from the larger one, giving it to the smaller, renaming it. It's all about renaming these work, not only just basic facts, but all the way through decimals, fractions as well. Renaming it in ways that are easier for our brain. It's going to become much more accurate, much faster, and build our number sense as well. Now, another strategy might be the bridge 10 strategy. The idea that I can take something from one of the addends and give it to the other addend to make a friendlier number. And beginning with basic facts, start with a 10. So if I see here, the top row is a 9 rod, which is blue, and the 5 rod, which is yellow. But you can see how that is the same as 10 plus 4. So we're also building that understanding of equality, because many times students think of the equal sign as being an action symbol, but it's not. It's a relational symbol. So the thought that I can have 9 plus 5, but I could rename it in my brain as 10 plus 4, because that's easier. And I'm not going to the additive phase of reasoning I'm not going back to the counting phase of reasoning to count on. So strategies, again, what we do with the numbers, the model is how we do making that thinking visible, and it can be concretely, pictorially, or abstractly. So when you think about fluency, what comes to mind? Basic fact fluency. In the chat bar, if you can just put any words that you have there that come to mind when you think of basic fact fluency. So I'm going to show you today how the basic fact, work we do with basic facts, can be extended to the larger numbers. I'm not seeing anything in the chat. Kristen, are you?
Flexibility with numbers, awareness of fact families, automaticity, accuracy. That's what I see.
All right, awesome. And I love those thinking. Typically what I see is speed and accuracy, and that is not what fluency is. So I want to share with you fact fluency that typically in my consulting work and giving presentations, when I do ask about words that are thought of in terms of basic fact fluency, and also the memories of learning math as a kid, it goes back to basic facts and lots of flashcards, confusing, memorization, hatred, really negative connotation words. And so when I ask why, what are those things coming to your mind for you with that? Time tests are something that people go right back to all of the time. And if it wasn't time tests that got them, it was fractions. So kind of these gateway things where people began thinking math was not meant for them, that they didn't have a math brain, which completely is untrue. Well, I was in the room when Marilyn Burns said that time tests had a birth, they can have a death. And I so believe that. I do not believe in time tests at all. I think there's other ways we can assess to find out how our students know and how they're thinking about and build their number sense and their flexibility with numbers. So fluency incorporates 3 items: flexibility, accuracy, and efficiency. So typically the whole speed and accuracy piece, that's not the definition of fluency. And so we want to make sure that all our stakeholders, including our parents, are understanding and have that common definition of fluency. So the journey of basic facts, typically our students have begun by, they're in a phase of reasoning, of counting. And then we ask them, okay, now that you're counting on, I want you to learn them all. And so the kids memorize them, and they're waiting for their brain to tell them a number when you ask them a fact. And typically we've measured how they were doing by giving them time tests. But I want to suggest to you a different pathway today. First of all, using the math tools to have number talks, which is asking about the quantities. How many are there and how do you know? Now, some students will count all the beads, so we know they're in a counting all phase of reasoning. Other students would begin with the 6 beads on top and count on the 7 on the bottom. But still others would count on the 6 from the 7. They'll know counting on from the larger addend will be more efficient. But yet others can begin the drive fact strategy, and they can say, well, I see that 5 and 5 is 10, because the color coding of the math tools we use can help facilitate using the benchmark numbers of 5 and 10. So if 5 and 5 is 10, I can see there's 1 and 2 more in the 6 and the 7, so I can rename it as 10 plus 3, which many of our students know is a 13 without having to count on the 3. Now, another student might say, well, I know 6 and 6 is 12. And in that 7, there's a 6 and then 1 more, so I know it must be a 13. Still, other students might say, well, I could break apart the 6 and give 3 to the 7 and rename it as 10 plus 3. So none of these are better than any others. It's just being using number relationships as the key. As we build that and have them practice their math facts using games that are allowed to let them talk about their thinking and share their strategies, We can then measure how they're doing. One of my favorite assessments is the math running record. Dr. Nikki Newton spent 10 years poring over the math fact research and codifying for us an interview protocol that allows us to find exactly where the students are on their learning journey for each operation, so we know where we can begin our work. That is so powerful right now as our students are coming back to us having had the virtual learning. We can know where to begin to work with them. So we can accelerate them from where they are right now, that asset-minded, and move them forward. So she's written a book called Math Running Records in Action. You can get that on Routledge site. I also facilitate a Facebook group called Math Running Records that we share all kinds of free resources about fluency for your students. And so just as an introductory understanding what a math running record is, there is a progression of strategies for each of the operations. And typically we want our students to be fluent by the end of grade 2 with their math facts for adding and subtracting. So with kindergarten, within 5, we're hoping by the end of the year they're fluent within 5 for addition and subtraction. By the end of grade 1, fluent within 10. By the end of grade 2, fluent within 20. And this is the progression. So during the running record, we're asking these in order because they get more difficult. So we can find out exactly what set of facts are causing them inaccuracies, super slowdowns, or inefficient strategies like counting on, right? Being in the counting phase of reasoning. So by being able to ask our students that's in part 1. Part 2, we do a deep dive. We're asking them other expressions in each strategy zone. We find out exactly what strategy zone they're working in, so we know we can begin our work there with them. And being aware also in the math running record of this developmental progression our students go through, being counting all. They will count each item of each of the addends. Then they will begin counting on, and they can be doing that with their fingers or still manipulatives. And within that, knowing they can count on from the larger addend, even if it comes second, is embedded within that work. Then they'll count on with mental strategies, counting on in their head. But the derived strategies, that's the key to flexibility. That's the key to building number sense. That's using number relationships. On our way to hopefully developing automaticity with the math facts. They have instant recall with them. They're recalling it from memory. But their journey to get there did not entail memorization with flashcards and rote memory. Very different journey. And one last really underlying pinning thing of our entire K-12 math journey is Pam Harris's development mathematical reasoning. Our students begin their world of mathematics in the counting phase of reasoning when they're young children, as well as through kindergarten. So kindergarten is the entire counting and cardinality. Additive reasoning comes into play using those derived facts. I can use my doubles facts to help me. I can break apart one addend to make a 10 with the other. That's additive reasoning. Multiplicative reasoning kicks in starting in grade 3, so 3, 4, and 5, and that would be having a multiplication math fact. Now, some students begin the multiplication journey counting, so they count each object of each equal group. Then they go to skip counting, but that's additive reasoning. So if our students doing multiplication work and they are skip counting math facts, they're not in the phase of reasoning we want them to be in. We want them to use multiplicative reasoning, such as partial products and number relationships again. So hugely impactful. And I want to show you today how we can use the math manipulatives to help encourage this and excel this learning for all of our students, accelerate them on that journey. So first of all, I'm going to be able to show you Braining Camp apps, several examples here. You can go to the brainingcamp.com site and you can redeem using this code, this hands-on 4 code. That will get you access for 60 days for the app for you and all of your students. So I highly recommend that you do that. So if you do that today, then you get the access to the Braining Camp app. It is a phenomenal site. First of all, you get access to 16 manipulatives. There's no limit to them because they're virtual, whereas such as Cuisenaire, my favorite manipulative, you have 4 in a student set of the larger rods. Of course, online, you get unlimited. So just want to mention to you that to have that redeemed today so you can get your 60 days access to Braining Camp. Now, one of the wonderful things that I love in the Braining Camp app is the fact that we can have share codes. Now, share codes are our way of being able to share with them a code that brings you to an app with something already on the screen that you've put there. Every student gets their own copy of that. They can then manipulate and do things with the manipulatives to solve it. Then they can share that work back with you, generating another share code. And I've had students even put those images of what they did on a Google Sheet, for example. So I can see all different ways students solve problems. So it's a great way to be able to communicate back and forth and for the students to be able to show you their thinking. So I've created a document for you. I just put that link in the chat bar. This is the hand to mind share. So it's a tiny URL. What that's going to do is it is going to open up a document for you. It's going to make you make a copy, which means that you have your own copy of this document. This is a starting place for you. You'll have these codes that I've created, but you can then change them all you want, copy any new codes you want, and just, I would suggest that you keep track of these codes because they never expire. So it's perfect to be able to start having your own library of tasks you've given the students and have that code. Those codes won't expire as long as you are a subscriber to Braining Camp. So what I've done here is I put a whole list of topics here that I wanted to go through with you today to show the progression. Yes, we are in a place of reality, and my puppy is barking. It's possible my husband might get home from work soon. Marty, or Marty McFly, he was so good. He's been nice and quiet. But in any case, so first of all, I want to go through with addition. So what I want to first just show you in the Braining Camp app. So this is a share code that I'm copying right here. I'll go to Braining Camp. I've logged in, and down at the bottom, I'll be pasting in this share code right in this bottom box. When I click go, it brings me into the app that I was in and whatever I had on the screen when I created that share code. So I always put things in context for students. There are 15 problem types that involve adding and subtracting. And if we don't know what they are, then certainly our students will not be exposed to all of those. But one of them is a part-part total where both add-ins are unknown. So Denise had 5 spools of thread. Some were purple and some were blue. What are all the possibilities of the colors of thread? So first of all, I want to show you, so if you're not familiar with Braining Camp, they have the manipulatives usually over here to the left. There are lots of options in the bottom of the screen. There's pens you can write with. There's a text box that I'll be showing you as well, but they've just added this within the last few days, a 5 frame. So that had always been 10 frames down there and arrays, but they now have a 5 frame. So for in this example, if I have a 5 frame, what I could do is I could then model, well, what if I had all purple ones? So I have my purple linking cubes and they were all filled in. And then I want to say, well, what if I do it systematically to be sure that I have all my possibilities that there are, I might think about, well, this one, rather than being purple, what if that were 1 blue and 4 purple? So I'd be able to then build this down, thinking about having all that were purple, but then 1 more each time being the blue. What would that turn out to be? And what I've done is I've made another code for you to show you, rather than taking the time right now, what that would turn out to be, what it would look like if I finished making all the possibilities. And again, doing it in a systematic way, I know that I have all the possibilities. So then I, of course, can notice patterns. So math is all about building and understanding patterns with numbers and shapes. So we always, when we're talking to our students, what do you notice? And what do you wonder? What patterns do you see? And students are going to notice this pattern, that this amount of the purple went from 5, 4, 3, 2, 1, and 0. And the blue was just the opposite. And as we can also do that pictorially by having them draw, let's say, on graph paper. But then abstractly, you can see with the equations, 5, 4, 3, 2, 1, the other addend was going up by 1. This is that relational thinking I was mentioning earlier, that if one of the addends goes down by 1, the other has to go up by 1 if that sum is going to be the same. I also intentionally put the 5 on the left-hand side of the equal sign, because we want students to understand equality as a relational symbol, that whatever value is on the left, we have also that same value on the right. And too often our students only see our sums and differences and products and quotients on the right-hand side of an equal sign. And that's not, so they think it's a calculation symbol. Oh, I gotta do some math. And it just leads them astray when we're trying to have some relational thinking. So that's the decomposition. This is the heart that we need set at the primary grade levels, so that we can then break apart numbers and be them, be able to use doubles, use the make 10 strategy, the nearest 10 strategy. If I break apart a number to make a 10, I've got to know how much is left. And I don't want to go back to the counting. So decomposition, one of the biggest things, remember, not just decomposing the numbers 5 and 10, those benchmarks, but all the numbers 5, 6, 7, 8, 9, and 10. Super crucial. Now, once we've built that foundation of decomposing numbers, we first do it within 5. Within kindergarten, we'll do it within 10 by the end of 10, but in first grade. But now we can talk about addition. So how do we think about adding numbers together? So again, I'm going to paste that code here in that share box. It brings you into the screen I was in the linking cubes. And I've given always, I love having context. So Jen had 6 seashells and she found 7 more seashells. How many does she have now? Well, what I can do is I can bring over a 10 frame. So they always have the structures here for us to capitalize on that benchmark of 5 and 10. If I want to put out the 6 seashells that she had, I can just click, and it's going to put it right in the 10 frame automatically for us. So I can just do my 6 right in a row. And then I'm going to want to have another 10 frame to do 7 more seashells. So I'll do that in blue. So I'm going to have 7. So I have the 6 seashells she had. These are the 7 that she found that were more. How many does she have now? And now we embark on a journey of how do we figure out how many all of these are? Well, first of all, I want to show you another new feature, which is the rotate. You can rotate the 5 and the 10 frames now. So you click on the frame, you click this button here, it gets rotated. So I love that, being able to see it also in this vertical way. And now students might remember that progression of counting on, and the drive strategies. They might count all up the cubes. They might count on 6 from the 7. But some derived strategy phases that the student can be doing is they can say, well, I see that this is 5 and that's 5. And there's just 1 and 2 more. So I can think of it as being 10 plus 3. Another student might be able to think, well, I know 6 and 6. So if I think of a second removing that one, that 6 and 6 is 12. And 1 more makes the 13, right? But I also can move some of these cubes. So I can take some of these. This is called conservation of number. The understanding that I can take items from one and move it, and I'm not changing the total amount. I am able to manipulate this. I'm not changing the total amount, but I'm making it easier for my brain. So I could filled a 10 frame. So I've got 10 plus 3. So the 10 plus 3. So all those variety of gradation of progressions of helping our students figure out that it was the 13 that she has now. So as we begin that adding, I want to jump all the way to fractions because I want to show you that this same thinking can then be transformed and used again down the pathway of our journey. And now I'm in the Pattern Blocks app. So we're adding, let's say, 5, 6 plus 3, 6. Now, I know in my 5th grade classroom, I had not known really anything about teaching virtually with mathematics. I did base 10 blocks. I know I did that for subtraction to do the regrouping method with our students. But I had never realized you could use pattern blocks to explore fractions. And so it was transformational for me and my brain to change. I now think visually about math, and I was not a traditional visual learner of math, but I've changed. We all have visual parts of our brain to allow us to learn visually. So let's think about 5, 6, and 3, 6. Typically, I know I did this in my 5th grade classroom. I used fraction tiles to be able to help my students understand that they can have 5, 6, have 3, 6, add the numerators, but don't add the denominators. And then it felt weird because we had 8, 6 as an answer, and that felt improper, like it wasn't okay. So then we had to go through a routine of how do we get a mixed number, an improper fraction into a mixed number by dividing and using the remainder as the numerator. And I know I lost a handful of my kids on that journey. It was not making sense to them, and that's probably why they felt that fractions weren't for them. And I feel like I did a disservice to them. I didn't know at the time what else I could do. But now that we know better, I do better. So Dr. Maya Angelou says you do the best you can till you know better. And then when you know better, you do better. And so now what I would do is for 5, 6, and 3, 6, first of all, we also want to think about 5, 6 as also being 5, 1/6. So 5 of those unit fractions of 1/6. 3, 6 is 3, 1/6. So if I have 5 1/6 plus 3 1/6, I have 8 1/6, right? So, and now what I can do is show that to you concretely. So let's take out 6 of these manipulatives. So 6 of these, the opportunity within Brain and Camp allows you to flip them. So I'm going to make my bottom 3. You can notice how that looks like a 1/2 actually. And so there's my, here's my 5/6. So I'm just going to flip that again. So I've got 5/6, and now I'm going to have 3/6. I'm just going to copy these bottom three just to be a little more time consuming. So if I'm adding 5/1/6 plus 3/1/6, I can decompose this 3/6 just like I had if I had 9 plus 6, taking 1 from the other addend. I can take 1/6 from the other addend because I know, and I can rotate this to make it fit, I know that 5/6 is just 1/6 away from 6/6. And I know that is the same thing as a 1 whole. So the idea that I can then take my 5/6 and 3/6, and I can even visually think of one of these filling that 5/6. Well, now I have a 1 whole and 2 more 6. And I didn't have to deal with, improper fractions. We don't actually call them improper fractions. You will not find that in any core standards. They're just fractions. They're fractions that happen to have a value greater than 1. And so the idea that I can break apart an addend and I can decompose numbers, we can decompose them as fractions. Then we can be able to think about, well, if I take away 1/6 from my 3/6, how much is left? Well, 1/6 and 2/6 makes 3/1/6. So it has that entire journey for our students, and it eliminates a lot of the places that they fall off the process because it's just rote memorization of all these different procedures, right? So addition, the heart of addition, we can use our doubles, facts, and number relationships, but also really helpful breaking apart one of our addends, whether it is multi-digit numbers, decimals, or fractions. We're building the number sense and using that same thinking to make it easier for our brains and our computational work. Now, with subtraction, I want to show you the Rec and Rec app. A Rec and Rec is a beaded Rec and Rec. This one is, we have 2 boards within, if this ever happens to you, if you ever find it tells you an error, you probably grabbed a space in addition to the code. So just be aware of that you just do it again and try not to get a space in there. And then you go right back. And so then you just type it into that, again, that code. And then you hope it works, particularly on a webinar that's live. All right, so this is the Rec and Rec app. You'll notice that in the bottom right-hand corner, each app has work mats. This is the basic work mat where you have 1 row of 10 beads. Now you can choose to have up to 10 rows of the 10 beads. But I'm in the work mat that has the 20 beaded row, and you can also do 10 rows of that. So you have enough to show 200 beads. But so I have an example here. There are 15 ducks and frogs in a pond. If there were 8 ducks, how many frogs were there? So what I want to show you is part of our journey of accelerating the learning of our students is also to pay attention to word problem structures and be able to see the structure of the situation and not just pluck the numbers out, as Graham Fletcher says, and compute an answer, and certainly not using keywords. There's a lot to problem solving. In fact, there are 15 problem types that involve adding and subtracting single step. And so what we can do now, another feature I want to show you is they've just within the last few days inserted shapes into Braining Camp, that you can now insert shapes. So what I can do is I can bring down a square. I'm going to make it a little tinier so I can fit it here. I'm going to then copy that, because you always have an option here now to copy. I'm going to be putting it right next door here. And then I'm going to copy it again, and I'm going to make one top. This model here, this tape diagram bar model, will work for any of the 15 problem types that involve adding and subtracting. And now if I use my words to label it, well, I know there are some animals in all. That's my total amount. So that's the number in this top box. And I know I have some frogs, and I know I have some ducks. So I'm modeling the structure of the story problem. I can then fill in the numbers as appropriate. Well, what I know is there are 15 animals, and I know that 8 of them are ducks. What I don't know, what I need to solve for, is how many frogs. So once I know that that's the structure and that's what I'm looking for, now I'm going to figure out the answer. But typically, we have thought to say, oh, well, that is a subtraction problem, right? But it's not. I don't have to use subtraction to solve it. It's a problem that where there's a missing addend, and I can think subtractively or I can think additively to solve that. So if I have 15 and I know 8 of them are ducks, the rest are frogs, I can slide over in one slide 15. These are color coded at the 5s. So I can use that number relationship that I know I have 15 beads in place. We always have them on the right, and then they're in place when they're here on the left. I know 8 of them are ducks. Now, some students might count back the 8. They're sliding back one by one. They are in a counting phase of reasoning. And then what happens is they see this and they count 1 to 7 to find that out. So you want to help that be more efficient, accelerate their learning from that by thinking about at least, I can remove 5 in one jump because 15 to 5 is 5. To remove 8, I have 3 more to remove. I know an 8 is made up of a 5 and a 3. And then how do I know how much this is? Well, I can use my benchmark of 5. It's 2 more than 5. Or I can think this plus this amount makes 10, and 7 and 3 make a 10. However, I want to think about that, but I'm trying to move beyond counting. Now, another student might say, well, I like to think about addition. I don't like thinking about subtraction. And the relationship, that inverse relationship always exists, that if 15 is made up of an 8 and something else, well, then that 8 plus something else must make that 15. And there's a button here that allows us to have that labeled. So you can see that the 8 and the 7 make up the 15 in all. And I could have thought additively about that. I could start at the 8 and think, well, it's 2 more to 10 and 5 more to 15, right? So I can have that total amount of 15, and then I can see, oh, I can have 8 and I can have 7. So we need to be aware when we're working with our students of where are they on that thinking journey of counting into additive reasoning as we're working with adding and subtracting with them, and modeling the structure of our story problems, putting things always in context to understand what the relationships are happening in those contexts. So now I want to show you the extension of that down the road with subtraction as we work with multi-digit numbers. This would be an example of 2-digit numbers. And I've chosen in this case to use the Cuisenaire rods. They are my favorite tool to use, particularly with double-digit adding and subtracting. And so, so with these, you have the models here. Now, I previously the shapes wasn't working. The shapes wasn't active yet. I'm going to use shapes right now instead. So if I have my model of my bring down my rectangle, I know I'm going to be having a part total situation. So I have this one, and I have this guy. I'm going to do another one and make him be all the way across. And then I have my words. It says there are 38 more oranges than apples on a grocery display. If there are 52 oranges, how many apples were there? This is one of the most difficult of the 15 problem types because it uses the word more, but what number are we trying to find out? Well, let's model it and see. If there are 38 more oranges than apples, well, then there must be more oranges than apples, right? There's 38 more oranges than apples. So the difference between those two would be another one of the boxes. It could be on either side. It doesn't matter which side you have it in. So now that I know this is the structure, well, now I can put in the numbers that I know. I know there are 38 difference between the oranges and the apples, and I know that there are 52 oranges, in which case I'm looking for how many apples there were. And once I've done that, well, now the sky is the limit in terms of my flexibility to be able to do this. I don't encourage using the algorithm this soon in the journey for a second grade because it's going to stifle their ability to be flexible. And very often in the algorithm, students are doing, well, in the algorithm, it needs you to work with basic facts. And very often in the basic facts, they're counting. And we want to do everything we can to move them into additive reasoning and not fall back to counting. So one way that I want to show you to build the flexibility that we could do is I had shown you in the earlier one how you could use addition to solve subtraction. And so what I can do is I can bring out my 52. So with Cuisenaire rods, you're able to rotate. In many of the apps, you can rotate what you bring out. There's also a button here that I can be bringing out them vertically. So 50, and then I need to bring down the 2. So I have 52, and I'm trying to think about 38. Well, then 38 plus something must make the 52. So if I take my only available in the digital world Cuisenaire rod that is adjustable to be whatever you want it to be, I can make my quantity of 30, and I'm going to make my 38. I can bring down this 2 units. So I'm just going to get that in place and bring it down. Sometimes it's a little finicky. There we go. And I brought it down 2 units, and I can show you that that's 2. So this must be the 8, a size of an 8, and there's the 2. Well, take a look at this. This is the distance between them, right? So I can concretely see what you can do when you're using the, because I've done this a lot with base 10 blocks with my students. What I do now with multi-digit work is I use the base 10 blocks for the rods and the flats, but I use Cuisenaire rods for the ones place because it really encourages that next moving into strategic thought. But now I can tell the distance is 14. It's 2 to get to 40, 10 more to get to 50, whoops, and then 2 more to get to 52. So 52 minus 38, or I can think 38 plus something is 52. Well, it is a 14. So I can get there in that flexible way. But again, that same thinking about sometimes when the numbers are closer together, I might want to use adding up to solve. And so again, the Cuisenaire rods, these tools will help us in our journey to use these benchmark numbers to help us, as well as to share these number relationships. That is the key to building number sense and that flexibility of number. As we jump in now into multiplication and just a couple examples of multiplication and division, I want to show you how in the colored tiles app that you could be able to talk about multiplicative reasoning. So going beyond the skip counting, grade 2 will be doing skip counting up to a 5 by 5 array. But as grade 3, as we're exploring multiplication, we're going to be having larger arrays, and we do want to help move them past the skip counting because that is a phase of reasoning, but it's not in the content we're exploring. So what I can do is I can take these sets of squares and I'm just going to bring them down below, and I'm going to do it 3 times just to show you some possibilities. Now you'll see that the array does measure 4 by 6. So each of these measure 4 by 6. How can I then think of it in flexible ways where I'll be building the heart of the distributive property of multiplication? Well, I know that I could think about the 6 as being 5 groups and 1 group. My 5 facts, maybe they're already strong. So I'm working on my, but the next ones in the journey. My 5 facts I already know. So I can change the color in the colored tiles, these colored tiles here. So now I can be able to visually see that within this 4 by 6 array, I have a 4 by 5, and I know that's 20, it might be a fact that I know, and I have 1 more group of 4. So the total is 24. But what if I want to think about it as being, well, I know that anything times 4 can be thought about double and double again. So 6 doubled is 12, and I'm going to double it again. And how about in this last one? Well, what if I want to break apart my 6 into 3 and 3? Because I know that 4 times 3 is 12, and all I have is another one of those, right? So I'm breaking it apart into partial products, and it's the sky's the limit, whatever the students want to be able to do to be able to break it apart. That, again, sets a foundation of flexibility of thought for the basic facts, but it's in multiplicative reasoning, and it can extend easily to larger numbers. If I learn that anything times 4 is the same thing as doubling the number and then doubling again, well, now I can multiply anything times 4. If I just memorize 4 times 6 is 24, whether I have rhymes or songs, I'm not set up for success and to be able to accelerate that learning into the content level that we're working on with our students. So rather than doing an algorithm for multiplication, let's say, if they're getting caught in all that steps, remember, multiplication algorithm also is single digit math facts. And very often kids are skip counting their facts, so they don't know their basic facts. But we don't have to work on them that way. We can work on it with the numbers and the place value. So here's an example of 8 times 35. Now, every multiplication problem, I just showed you those arrays, every multiplication problem will result in a rectangle. So I want to be able to make an area model here. And in fact, I can even draw that with the shapes app here, that I'm going to come up with one rectangle. It's going to measure 8, and it's going to measure across the horizontally by 35. So once I fill out the inside of this rectangle, when I add up the quantities of all this, it's going to be the product of 8 times 35. So how can I do that? Well, I can bring down my 10 rod and make it horizontally. I can also do horizontal again. What if I think of it as being 8 35s? So I want to build my 35 first, and I'm going to bring down 5 more ones. Once it's in place, you can just click on the same one, it will go automatically. So I have my 35, which means that I can move it within a rectangle. I can then copy it. So this is now 2 35s. Here's 3 45s, 4 35s. I'm getting to 8. Now, the total value won't change unless they're touching together. So you do want to make sure that they're all touching. I want you to be able to see that. Let me get that rectangle out of the way for a second. So as I'm filling in these, I'm going to just do this one again, the total amount, get that clicked in. I'm going to build up my 8 and just one more. Now, this rectangle then, one way I could have partitioned it would be think of place value. I could do 8 times 30, which is 240. And then I could do 8 times the 5, which is 40. But I do want to suggest to you, what if instead, what would happen if I took 4 rows of this? What if I took this 4 rows? I think the rectangle there is causing a problem. I want to highlight these 4 rows of 35. And I'm going to slide them over to here. Now you'll notice the 280 did not change. I still have 280 in this rectangle. The rectangle that was here, I cut it in half and slid it over to here. So what happened to the measurements of my rectangle? Well, these were reduced. Those 4 went away. It's now a length of 4. And then this one across the top, 35, didn't it double? So I just renamed 8 times 35 into 4 times 70, and it's 280. That is the acceleration we can be doing with our students, that we're not limited by algorithms to build their number sense. When we think about number relationships, when I think about that's called a double and halving strategy, but really it's a relationship. I also could triple and third or quadruple and fourth. But to begin with, double and halving, if I have an even number, I can have it and double the other factor, and maybe it's easier numbers for my brain. I don't have to go to the partial products that are only by place value position. We might be able to encourage even some more mental math with that. So that, just as an idea there of the area model being the most powerful model, the area model, we can begin colored tiles as we have with basic facts. We can extend it to multi-digit work. And now take a look at this. It's also appropriate for decimals. So let's say that I'm thinking over here, we first want to think about our objects. We're going to rename in the base 10 world that the length of this side is 1. So that length is 1. Oh, I should have drawn a line with the shape, sorry. And then this line is a distance of 1. And so what's the area inside? Well, this will be 1. So we're not using like base 10 blocks now, we're using it in a new set of numbers, but that flexibility of math tools is really important. When I have this rod here, well, what is the distance, the length? Well, this is a length of 1, and this is a length of 1/10, right? Because 10 of these fit into here. So if I have a 1/10 by 1 rectangle, its area is 1/10. It's a 10th of that whole. Now, how about this guy? What are the measurements of this side and that side? Well, that measurement is a 10th by a 10th. Well, what's the area of that? Well, that's 1/100th, right? This cube is 1/100th of this whole, so it's worth 1/100th. So if I want to model for you 1 3/10 by 1 4/10, what I can do is it gets a little confusing with the area and the distance when I use the base 10 blocks for modeling the sides. But if I have a 10th, and then I have, I have a whole, and then 3 more tenths, and then I have a whole, and 3 more tenths, 4 more tenths going horizontally. Well, now I can build my partial products. I can think about a 1 by 1 measures of 1. I'm then going to do a 1 by a 10th. So I would have 4 of these. right? This side down here, I would have a rectangle that measures 3/10 by 1. And then this area, I have a 3/10 by 4/10. So I'm going to be taking 12 of my cubes here. So I have 1, 2, 3, 4. And then I'm just going to copy those. As they are a group, I will copy those to have 3 rows. Now, as I put these together to make one full rectangle, again, every multiplication problem, even with decimals, fractions, will result in a rectangle. Now, I'm going to delete these particular cubes here just to get the value. You'll see that the value is 1 82/100. When you think about the partial products, a 1 by 1, that area is 1. The area over here is worth 4/10. It's a 3/10 by 1, so it's 3/10. And then we have our 12 100ths. So that same thinking that we did with the basic facts and the colored tiles extends now to the decimals. And I do have one more example for you that I just want to show you quickly, and that is division. Because division, we can use that area model to solve division problems. So in division, we're trying to find the largest rectangle that we can. The inside will be the product, right? I'm sorry, the product of these two factors. So if I have 172 divided by 4, well, I can think that 4 times something will give me 172. And if I can figure out that horizontal distance, that's going to tell me what the quotient is. So what I can do is I can bring out the 172. Now, I'm going to bring it out just right now in tens just to save time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll go up to 170. Only because it's going to be a burdensome to regroup and take away that 100. But so I'm going to do 72. Now, what I can do is I can take these and I can put them to make a row of do I have enough for a 4 by 10? Well, yeah, that would be 40. I have enough for that, right? So I can build a 4 by 10. Let me just rotate that. So if I have enough to build a 4 by 10, do I have enough for a 4 by 20? Well, yeah, I do. 4 by 20 would be 80. So I can just copy this. And I have enough for a 4 by 30. And I'm going to take away the 40 that I just did. So those 40 are going away. Do I have enough for another 4 by 10? Yep, that would get me to 120. I'm almost there. So I'm going to get rid of those 4 that I just took care of. And then I can do another 4 by 10. Oops, my goodness, didn't mean to do that. So I have a 4 by 10, and now I have enough for another 4 by 10. So it turns out that 4 by 40 is 160. I'm only 12 away from the total amount. And of course, sometimes you might have a leftover remainder, but so here I have 12. So I want to make my 12. I'm going to do just another row of 3. I'm sorry, a row of 4. Well, we speak a column of 4. And then what I can do is I can then copy that. So if I have my column of 4 and I copy it and I copy it, I'm on the decimal work mat. This is a really hidden gem within the base 10 blocks. This is called the factor mat. So on the bottom right hand corner, you've got different work mats. This is the factor work mat. And so as you can see, I want to just get those off the screen, that I have, it measures 4 coming down this rectangle. And what is the distance across? Well, it's 40 plus 3 more. So now I know that 172 divided by 4 is 43. So the key to accelerating our learning of our students is to be using models and strategies that will follow them through their entire math journey. I have a quick story for you as we wrap up. This is Kathy Palkovic, her 3rd grade classroom last year, the 1920 school year, that she'd been doing counting collections with her students and exploring flexibility with numbers. And it was before February vacation, and they had a donation of some decks of cards for a family math night that we never actually ended up happening because the pandemic hit. But she wanted her students to figure out how many boxes of cards were in the 6 boxes of cards. Well, they ended up organizing them in piles of 10s and then put the piles of 10s in 10 frames because they were used to doing that in their counting collection routine. And so they had across the classroom all these piles of 10s, tens of 10s, so they knew that that was 100, and they determined that there were 898 decks of cards. And then a student said, well, I wonder how many cards that is. Now, these are 3rd graders, and it was February. So very often, I do know that I hear from teachers a lot about multiplication math facts, that the kids aren't mastering them, but we can accelerate their learning by using flexible strategies. They figured out 898 times 52 by thinking about 900 times 52, and they removed 2 52s. So the possibilities are endless when we do explore these strategies in these flexible ways that open the door and apply all the way through their learning journey. I do have in the handout for you some links that I am an affiliate for Hand to Mind. So if you ever have any Hand to Mind materials that you want to buy, I've been able to make my own lists within their site for K2 items, 3, 5, as well as Cuisinart. I've given you those codes. This is the book I wrote with Dr. Nikki Newton and Dr. Allison Mello, all about fact fluency with addition and subtraction and exploring it with concrete, pictorial, and abstract ways. You also can feel free to sign up for my newsletter. I've got online workshops and consulting work that I do. You feel free to contact me at any time, and as well as online as well, Facebook and Twitter and Instagram. So I just want to thank you. And my last note is there is nothing elementary about teaching elementary math. But if we go into this, certainly right now with our kids and going into next year, asset-minded, what do we want to do with our students to help move them forward? Let's find out where they are. And we do have these ways to help accelerate their learning and unlock the future math journey for them as well. So thank you so much for joining in. I'm happy to answer any questions that you have.
So, you know what? The only thing that I'm seeing is really nice comments. Like, just what an amazing session. This was an inspiring workshop. So you were thorough. There are no questions, and I'm going to be cognizant of everybody's time. Could you one more time really quick though before we end? You will get a certificate. I do see that. It will come automatically, Megan. So in about an hour, hour 15 minutes, check your folders and make sure, check your junk, check your spam. It might filter it if it's a school email, but it will come. It will say thank you for attending the webinar in the subject line. And then the code. Yes, they would like the code for Braining Camp again.
Oh, sure. Let me just.
I can type it in the chat box if it's easier. And yeah. I just put her email in there too, if you want to copy, paste it, save it, whatever works. Okay, so what is it here?
It's hands-on 4.
Okay, hands-on 4. All right,
and all
awesome.
you do is you go to the brainingcamp.com site, you click on redeem, you enter in that code, and there's nothing to set up. You only set up one username and password, and then all your kids get into it.
Mm-hmm. Yep, and then I also put a link to see Braining Camp from the Hand to Mind site in the chat box as well, so you can go in either place. Be on the lookout for Ann Elise's blog in the next, few weeks. We love when she does a webinar because she writes an amazing blog post as a follow-up. And thank you, Ann Elise. That was great. I think they loved it. So we certainly appreciate you joining us. Everybody, thanks for coming. We hope you have a good rest of the day and a good rest of the school year, and hope to see you again.
Yes, take care, everyone. Take care of yourselves as well.
Take care, guys. Bye-bye.
Bye-bye.